An electric car, also known as an electric vehicle or EV for short, operates primarily using electricity as its power source instead of gasoline or diesel. Here's a basic understanding of how electric cars work and their key components. Let's delve deeper into the components, operation, benefits, challenges, and future outlook of electric cars. Components of an electric car.
Power electronics. The purpose of power electronics is to control the flow of electricity between the battery pack and the electric motor. It includes inverters to convert direct current power from the battery to alternating current power for the motor, and direct current to direct current converters to manage lower voltage systems.
Charging system. There are a few types of charging systems. First, we have level 1, which uses a standard 120-volt household outlet. This provides slow charging and is suitable for overnight charging. Next is level 2, which uses a 240-volt outlet or a dedicated charging station. It offers faster charging rates, typically adding 25 to 30 miles of range per hour of charging. Then, there's DC fast charging. This provides rapid charging, capable of adding up to 100 miles of range in about 20 to 30 minutes. It's commonly used in public charging stations. Lastly, we have the onboard charger, which converts alternating current power from the charging station to direct current power for the battery.
Regenerative braking system. The purpose of regenerative braking is to recapture kinetic energy during braking and deceleration. When the driver lifts off the accelerator or applies the brakes, the motor reverses its function to act as a generator, converting kinetic energy into electrical energy. This energy is then stored in the battery. Electric Vehicle Control Unit, or ECU, manages and coordinates the operation of various systems in the vehicle. This includes the electric motor, battery management system, regenerative braking, and safety systems. It monitors temperature, voltage, and state of charge of the battery to optimize performance and ensure safety.
Let's talk about the operation of electric cars. Charging an electric car involves plugging it into an electrical outlet or charging station. Charging times, well, they vary depending on the type of charger and the capacity of the battery. The driving range on a single charge varies by model and battery size, typically ranging from 100 to over 300 miles or 160 to 480 kilometers. Now about driving dynamics. Electric motors provide instant torque, resulting in quick acceleration and smooth operation. Single-speed transmission systems are common in electric cars due to the wide torque range of electric motors. When it comes to maintenance, electric cars generally require less maintenance than internal combustion engine vehicles. They have fewer moving parts, no oil changes, and fewer components subject to wear and tear. Maintenance typically involves checking the battery health, electric motor, brakes, tires, and ensuring software updates are applied.
Let's talk about the benefits of electric cars. First up, the environmental impact. Zero tailpipe emissions reduce air pollution and greenhouse gas emissions, contributing to cleaner air and mitigating climate change. Next, energy efficiency. Electric motors are more efficient than internal combustion engines, converting a higher percentage of electrical energy into motion, typically around 85 to 90% efficiency. Cost savings are another major benefit. You'll find lower fuel costs compared to gasoline vehicles. The cost per mile to charge an electric car is often lower than the cost per mile for gasoline. Plus, there are reduced maintenance costs over the vehicle's lifetime due to fewer mechanical components requiring servicing. And let's not forget performance and comfort. Smooth, quiet operation with instant torque provides a responsive and enjoyable driving experience. Also, the lower center of gravity due to the battery pack placement improves handling and stability.
Now let's discuss some of the challenges. One of the primary concerns is range anxiety. This involves worries about the limited driving range of electric cars and the availability of charging stations, especially in rural or less developed areas. However, advances in battery technology and expanding charging infrastructure are addressing these concerns. Another challenge is the charging infrastructure. The availability and accessibility of public charging stations vary by region and may require planning for long-distance travel. Then there's the upfront cost. Electric cars often have a higher initial purchase price compared to similar gasoline-powered vehicles, although this is decreasing as battery costs decline and economies of scale improve. Lastly, battery technology. Although lithium-ion batteries are currently the standard, advancements in battery technology are ongoing to improve energy density, charging times, and overall longevity.
Looking ahead, the future outlook for electric cars is quite promising. Continued advancements in battery technology are expected to improve energy density, reduce costs, and extend driving ranges. The expansion of public and private charging infrastructure is crucial for widespread adoption of electric vehicles, supported by government incentives and private investments. We're also seeing increasing adoption of electric cars across different vehicle segments, including passenger cars, SUVs, trucks, and commercial vehicles. Finally, the regulatory environment. Government policies and regulations promoting electric vehicles and reducing emissions are driving market growth and innovation in electric vehicle technology.
In summary, electric cars represent a significant advancement in automotive technology, offering environmental benefits, energy efficiency, and improved performance compared to traditional gasoline vehicles. As technology continues to evolve and infrastructure expands, electric vehicles are expected to play a pivotal role in the future of transportation worldwide.